So, logarithmic functions. So, the logarithmic functions to the base e, where e 0 and e not equals 1 is defined. So, y equals to ax if and only if x equals ay. So, logarithmic forms exponent form. So, when you convert the exponent to log form, notice that the exponent in the exponentials becomes with the log is equal to. So convert to log form. So 16 equals 4 over 2. So log for 16 equals 2. So convert it up to exponential form. So 10. So log logarithmic to 1 over 8 equals negative 3. So 2 over negative 3 equals 1 over 8. So log's exponent. So within in the mind we can answer questions about the logs. Log logarithmic to 16 equals 4. So this is making for exponent. What the exponents to do, put the base of 2 to get 16. So 2 to what is 16? So logarithmic 3, 1 over 2 equals negative 2. So what exponent do you put in the base to get 1/2? So and think negative. So look at it, logarithmic 4. So 1 over 4, 1 over 1 equals 4. What exponent you do put the base of the 4 to get 1? So logarithmic 3, square root of 3 equals 1/2. So when you working for the logarithmic, we write the radicals and rational exponents. Exponent, what exponent to do with the base of the 3 to get 3 to 1/2. So example 1. Solve the for x logarithmic 6 equals 2. So solve solutions. Let's write the problems in the exponents form. So 6 over 6 2 equals x. So we're finished. So example number 2. Solve for y logarithmic 5. 1 over 2 equals y. Solutions. We write the problems of exponents first. So 5 over y so equals 1 over 25. 5 over y equals 5 over negative 2. So y equals negative 2. So since 1 over 25 equals 5 over negative 2. So example number 3. We evaluate logarithmic 27. So solution tries it like this. So logarithmic 3 into 7 equals y. Now write the exponent form. So 3y equals 27. So 3y equals 3 over 3. So y equals 3. So example number 4. Evaluate logarithmic 7, 7, 2. Solutions. So logarithmic 7 over 2 equals y. First, we write the problem with the variables. 7y equals 7. Now, take it out of the logarithmic make form. So y equals 2. So example number 5. Evaluate 4 over logarithmic 416. So solutions for logarithmic 460 equals y. So first write the problems of the various. So now take it the exponent form of the right logarithmic form. So just like 2 over 3 equals 8, converts a logarithmic equals 3. So finally, we want to take a look of the property of equality for logarithmic functions. For first p to 0 and b not equal 1. So then logarithmic bx1 equals logarithmic bx2 if and only if x1 equals x2. Basically, with a logarithmic function, if the base of much of the both sides of the equal signs that simplifies it of the arguments equal. So example number 1, solve logarithmic 3 for x plus 10 equals logarithmic 3 x plus 1 solution. Since the bases are 3, both 3, we will simplify. Set the argument equals to 4 times plus 10 equals x plus 1. So 3x plus 10 equals 1. 3x equals negative 1. So x equals negative 3. So example number 2. Solve the logarithmic log 3 6 over 2 x squared minus 40 equals log 8 5x. So solution. Since the bases are both 8, we simplify it argument and equals to x squared minus 4 equals 5. So x squared minus 5x minus 14 equals, that is a fraction, so x minus 7 x plus 2 equals 0. So x minus 7 equals 0 or x plus 2 equals 0. So continue on the next. So x7 equals or 6 equals negative 2. So example number 2, solve the 8 x2. So the 14 equals to log 8 5x. So 7 negative x or x equals negative 2. So it affirms that we have a solutions here. So if you take a look at definition of the logarithmic, however, we'll see that only must be a positive basis, but also with the argument must be positive will be, therefore negative 2 is not a solution. So let's end the lesson by making a closer look at this bit. So our final constant is to determine by logarithmic the uh, the one below of the log 2 minus 8. So can everyone give us an explanation? So look at 2 negative 8 equals under 5. Why? One is the explanation is to simplify, write this logarithmic in exponent form. Well then y is negative value is not permanent. So limit to negative 8 equals y. So first we write the Franklin's proposals. Now take 8 logarithmic from the right of exponent. So y 2y equals negative 8. So what happened to gives negative 8? So 2 3 equals 8 and 2 over 3 equals 1 over 8. So since expressions of types are in the fine. Oh, characters about the graph exponential functions. If x equals x e1, so the domain is a real number, so range is positive numbers. There are no x except because there is no x values that you can put of the functions to make it equal 0. So the y-intercept is always 0 1 because a 0 equals 1. So the graph always increases. The axis where y equals 0 is the exponent for the x infinite of g negative 8. So characters about the graph of the current function. So fx equals log a where e1, so range is all real numbers, the domain is positive real numbers, so there are no y-intercepts, so the x-intercept is always 1 0 x s and y s. Regardless, the graph is always increased. The y-axis where x0 is a vertical exponent. So exponent graphs of the inverse functions of information about the line y equals x. So logarithmic graph. So you can see that is a logarithmic graph. So transformations of functions apply to functions just like they apply to all the others. So let's try a couple. So fx2 plus log 10 x. So fx log 10 x plus 1. So left 1. So with f2. So reflect about the fx equals negative 10x x. So remember our natural base a, we can use the base a log. So log a 2.71718282 I e to 8 equals 1. What is it to be? So since the logarithmic is the course of natural frequency, it is called the natural log and is the action in. So in 2.718282 so the calculation know how to find natural log. So locate the in button of your calculators. Notice that it is the same thing k that has ax above it. So calculation less functions inverse using the same k, but one of them needed to do it to or the button. So another commonly is used the base 10. So log to this base is called a common log. So since it is common, if you don't write in the base of On a log, it is understood to be used 10. So, what exponent to put in 10 is get 100. What exponent to put and this? So, the this common log is used to things like register scales of earthquakes and these helps for our sons. So your calculator know how to find common logs. So locate the log bottom of your calculation. Equations note it is the same k of the 10x above it. Again, the calculator lists functions and inverse using the same k for of them in second or inverse bottom. So the secret of solving our equations to write the arithmetic exponents from sub so log to 2x plus 1 equals 3. So that is to convert this equation form. So 2x equals to 2 over 3 equals 2x plus 1, 8 equals 2x plus 1, 7 equals 2x, 7 over 2 equals x. So checking log to 2 over 2 plus 1 equals 3. So log to 3 I 8 equals 3. So this is true since 2, 2, 3 equals 8. So that's all the answer.